Hello physics students. So it's that time of year again where you have to start thinking about what courses you want to take next year. And because we're not in school, I'm unable to answer any questions you might have about one of the options, the AP Physics, Electricity and Magnetism course. Now the first possible question I want to answer is what kinds of careers eventually have to get through a course on physics, electricity and magnetism? Well, one obvious one is if you want to major in physics. If you want to major in physics, then obviously you're going to have to study electricity and magnetism at some point in your studies. But a lot of people don't realize any science major has to take eventually a course that involves physics, electricity, and magnetism. Even chemistry majors, even biology majors. Think about the brain and the electrical signals and muscles and nerves. You have to understand electricity to understand any living being. So any science major. It turns out any engineering major, if you're thinking about any of the engineering branches, you should seriously consider the Physics, AP Electricity and Magnetism course. So obviously electrical engineers, but even mechanical and civil engineers will probably have to take or likely take a course that involves physics, electricity, and magnetism. Even medical students, people say, I don't need AP Physics, Electricity, and Magnetism because I'm going to study to be a doctor. In my life, I've tutored several people who were trying to get into medical school. In the medical school application process, you have to take a test called the MCAT, which is basically like an SAT test, but for medical school. So you obviously want to get your score as high as possible to get in. So yes, I tutored these people because part of that test, 1/3 of it was physics, and they had to know electricity and magnetism very well to get a high mark to even get into the very competitive medical school. So all these kinds of majors, you should consider AP Physics. But you might be thinking, well, why do I want to take it in high school? Why not wait till I'm in college? Well, there's a few reasons why you would want to, if you're thinking of those career paths, you want to take this course in high school. One of them is that, one, you might get AP credit and not have to take it in college, which would be nice. But another possibility is even if you don't score high enough to get AP credit or the college doesn't accept the credit for electricity and magnetism, then you will have to take this course in college eventually. And so it's a good idea because the course is pretty challenging, has a lot of challenging ideas. It's a good idea to learn it in high school so that when you take the course again in college, you'll do even better because it'll be second time around. And also think about this. You may have heard stories about colleges. Well, let me tell you one thing. Most college courses meet 3 times a week for like a period. Some of them meet 2 times a week. Compare that to a high school course where you're meeting 5 days a week, okay? Every other day, 90 minutes, and then the other day, 45 minutes. Much more time, much more attention to have your questions answered with a very challenging topic. And then also think about the tests. You may have heard that in college, a lot of courses have 2 tests, a midterm and a final exam, and that's the whole course. So obviously in high school, we have more quizzes, more tests, more labs, so more opportunity to sort of get feedback. And another challenging thing about colleges, I'm sure you've heard this too, giant lecture halls. You walk in, there's 300 people and one professor 3 times a week for one period. Not really going to get much help that way, that much attention. In high school, these courses are 10 or 15 students. You'll get a lot of attention to get all your questions answered. So another question people ask, well, is it hard? Well, I would answer that question with an analogy. If you're climbing a staircase, and suppose that staircase is your education to your career, it's hundreds of stairs to get to the point where you graduate to get your diploma and get your job. So along the way, you go from step 100 to 101, then from 101 to 102. 102 is higher than 101. So that's basically like the analogy between AP Mechanics and AP Electricity and Magnetism. You climb the stair in your educational process to get through mechanics. The next stair will be electricity and magnetism. Higher, you'll learn more sophisticated topics. But I would say, climbing-wise, it's no more difficult step 100 to 101 compared to 101 to 102. You are going higher, but the step is about the same effort. And what that means is that if you're going to take this course, it'll be about as hard as mechanics was for you. If you got a B in mechanics, typically students get a B in electricity and magnetism. If they get a 5 out of 5 in mechanics, they typically get a 5 out of 5 in electricity and magnetism. So don't be intimidated by, oh, it's harder, and so I shouldn't take it. Anyone can take it that's gone through mechanics. Now, the last thing I want to just sort of talk about briefly is what we even study. So you kind of get a sense of maybe if it's even an interesting course, if this would interest you or not. So what you concentrated on in the mechanics course is you concentrated mostly on models of motion. You recognize Newton's second law. And what this is telling us is how the universe evolves based on what forces apply on an object. It produces an acceleration, and therefore you could determine the motion of the object. But even energy and momentum conservation come directly from Newton's second law and third law. So Newton's laws is the heart of what you learned, and it's basically answering, well, why does motion happen? What are the things that affect motion? And can we determine that motion? Yes, through these analysis. But also, another thing that you may not have time for this year because of the pandemic, but another thing that sometimes we include in the mechanics course is Einstein's theories. Einstein discovered the errors in Newton's laws, and he formed a new set of theories. And then even more amazing, this is an amazing theory, even more amazing is quantum theory, in my opinion, some really wild stuff. But all of these are just different models of motion. But the question is, what are the forces? And you might be thinking, well, in mechanics, I studied force, I know what they are. I've got string tension, I've got spring force, I got normal force, I got friction force, I got centripetal force, I got, I don't know if I mentioned friction, normal force. You could start listing all these forces, and I got people pushing, and it come up dozens of different kinds of forces. But it turns out that in nature, there's only 4 kinds of forces in nature. 4 big categories, which means those forces that you studied in mechanics have to fit into just 4 categories. So we, in electricity and magnetism, start expanding what is even force, okay? So here are the forces: the strong force, the electromagnetic force, the weak nuclear force, the gravitational force. Strongest, weakest. In the mechanics course, you studied gravitation in quite a bit of detail, but one of the things that you probably won't have time for because, again, the pandemic, is the Einstein's theory. He revised gravitation. Really blows your mind. Revolutionary stuff about space and time warping. But anyway, you got a sense of this force of gravity pulling. But think about your everyday experience. Gravity is just like you falling to the floor. But as you're going through a day, there's forces all over, the wind blowing on you, people bumping into you, clothes on your body. What are all those forces? What are the spring force, the tension, all those? Where do they fit among these 3? Well, these 2, they occur in the nucleus of an atom. So I'll just put X's like that because in your daily life, you never experience those. You can't feel those. They're inside the nucleus, so you don't have access to feeling that. What that leaves is the electromagnetic force right here, which is the subject of this AP course, Electricity and Magnetism. Everything you experience is some manifestation of the electromagnetic force except for your body weight falling down. For example, let's take your 5 senses. Touch. I touch this whiteboard. The clothing on my skin touching me. I feel those things. That's the result of the atoms in one object contacting the atoms of another object. But what part of the atom? Well, An atom is protons in the middle and electrons orbiting around. And that's for both objects. So what happens when my hands touch like this and I feel one hand to the other or touching anything is the electrons in my hand get close to the electrons of the other object, and negative repels, and that's the sensation of touch. So any touch you feel, that sense is the electromagnetic force. What about taste? Well, imagine this. Food is bland, so I sprinkle some salt on. Now it tastes good, right? So what's happening with the salt? Salt, as you know from chemistry, is sodium chloride. Those molecules dissolve on my tongue, and I've got a positive sodium ion and a negative chlorine ion touching my nerves. Delicious, right? So touch and taste, okay? By extension, smell works the same way. I cook a burger or something, and all those molecules come into my nose, and they're electrically contacting my, smells delicious. So touch, taste, smell. Hearing. Hearing is vibrating air molecules in your ear. The molecules are colliding against your eardrum, negative repulsion, causing your eardrum to ricochet, and then your brain to interpret that. Hearing, 4 senses. And lastly, the 5th sense is vision, okay? And what is vision? Well, it's light coming into your eyes. And one of the things that we learn in AP Electricity and Magnetism is that light itself is nothing more than vibrating electric and magnetic fields. So in terms of understanding the universe, this is most of your physical experience. It's also what's causing the atoms to even have structure, keeping the electrons in orbit. So atoms wouldn't be possible, molecules wouldn't be possible, life wouldn't be possible, you wouldn't be possible without this force. So if you're the kind of person that likes to think about the universe and understanding it, you really need to understand this. Obviously, generating electricity and all the electrical effects, technology, all part of the picture. Your cell phone is vibrating electric and magnetic fields. So if you want to understand how a text message works, you send a message and it could go all the way around the world to someone on the on the other side of the earth. How did that happen? Electromagnetic fields vibrating the electromagnetic force. So this is so deep to understanding the universe that some people even get a little creative, a little poetic with the physics. Ultimately, all of electricity and magnetism can be described or modeled by something called Maxwell's equations. And that brings me to my shirt I have, which actually I got as a gift in college, and then the old one sort of faded and wore out, so I got another one. And here it says, it takes basically like the biblical passage in Genesis. It said, God said, let there be light, and then there was light. So it takes the sentence and sort of, plays with it. It says, and God said, and then all of these equations are Maxwell's equations, which are the part of the electromagnetic theory. So God said this, and then there was light. So kind of like, physicists trying to brag about how great and divine this knowledge is, So obviously the course isn't about religion, but I'm just pointing out that this is so deep, electricity and magnetism, that some people, sort of try and express how deep and awe-inspiring that knowledge is. So that's electricity and magnetism. The course ends with you trying to decipher and understand these equations. And it's a really fun process. Getting to that point, understanding electricity, electric fields, magnetic fields, that's the course, AP and Electricity and Magnetism. I hope I answered your questions. If you have any more questions, you could always email me, look me up in the school directory. I'm Mr. Tupaj, and just look that up, TUPAJ, and you could send me any question. I'll try and help you decide if the course is for you. All right, well, I hope to see you in the course next year. I hope we have a lot of fun next year, and good luck with the rest of the year. See you soon.